G'day YouTube, Warbles on a lot here. Those of you familiar with the channel will know that yesterday here it was cold and I spent pretty much the whole day sitting inside feeding the fire. And that meant I burnt a lot of firewood, and this little old potbelly is a pretty dusty unit. And that meant that the Peltier unit ran for 18 hours yesterday doing its aerodynamic thing. And whereas previously I videoed that with smoke trails, it turns out that 18 hours of dust accretion gives us a pretty good idea of what's happening on what part of the blades. Look at that. That's the underside of the blade. And the leading edge. And that's what's having the most contact with the air at the highest pressure, and that's sticking the dust to the surface of the blade. Oh, that's really, there we go. Interesting trick. Videoing while holding the light just exactly right. Change the angle of the dangle just slightly and you can see that the upper surface has virtually no contact with the dust. Once it gets past the first 1 or 2% of the leading edge. Oh, that one's got more. That's the thick one. It's suffering boundary layer separation much earlier on in the process because it's a thicker aerofoil. Damn, I'm going to have to do this same test at some point with both of these as well, I suppose, if we want to be truly scientifical. This is the blade that's got the correct aerofoil section. And this is the one that's slightly too thick. Yeah, it's really hard to show that. If nothing else, this gives you an idea of the tip tracking error. Not actually quite as bad as I thought it was. Anyway, there you go, dust accretion studies. That's the side that's doing the work. That's a side that's too thick. And because it's got a slightly too thick section, it runs into more air and picks up more dust, makes more drag. Yeah. If you haven't got a proper wind tunnel, you have to do things differently. See how we go from here. Oh, that's not bad there. As soon as you get past the first millimetre of the leading edge, the air bounces up and carries the dust past the low pressure surface. So there you go. That's a true definition of small things amusing small minds. Airscrew boundary layer determination studies using Dust-Accretion. On the blades of a miniature helical laminated wooden airscrew. A propeller rather than a turbine rotor. And as you can see, by where the dust is sticking on, the entire thing is working. Probably, well, I'll have to do the maths on it, but 95% of the disc area is a functioning airscrew. That's why I reckon it's worthwhile doing to carry the helical pitch all the way into the hub. Not stopping it about here and having the inner section of the blade purely functioning as a streamlined strut, while the outer 2/3 to half of the blade does all the work, allowing for the fact that one chord length is going to be functioning as a tip fence to prevent the low pressure area up here sucking the high pressure area around the tip. So yeah, whoops. When a propeller is in operation, one chord length of the tip is functioning as a wingtip fence for the rest of the blade. So your standard propeller, it's got a donut of actual functioning aerodynamic blade with a helical pitch. Inboard of the donut that's functioning, they don't do much because it's a streamlined strut carrying the working blade. And outboard of the donut, you don't do much because you're just generating a tip vortex and thus fencing off the inner working portion of the blade. I can't do much about the tip vortex, but at these low speeds they're not going to be too bad. Going for what they call these days in racing quad terms a bullnose propeller. I've maximised the amount of functioning blade that I can cut out of a plank 1 inch by 8 inches. And it seems to be working pretty well. Oh, look at that. Yeah, the whole blade is functioning. So says the Aero Hillbilly Enterprises Dust-Accretion wind tunnel studies. 18 hours worth of dust. Yeah. as a mad scientist. Warbles on a lot. Is very, very, very pleased with himself today. Ciao.